Okay, so this is number 15 from that packet, and this one does not have to do with curve sketching. I just kind of threw in a random question in there. So the question is, when is this graph over here going to be parallel? When will the tangent line be parallel? So that's the notation for parallel to this line here. So all you have to do is consider what is the relationship between the slopes of parallel lines, and they're the same. So first, if you take the slope of this one, you can just take the derivative, use a power rule, and you're just going to get x. So the slope is just x. Okay, and then for this one over here, this is just a line. So if you move things around, if you subtract 3 from both sides and then add 4y to both sides, then you could divide every term by 4. And you're going to get y equals 1/2 x minus 3/4. So the slope of that one is just 1/2. So when are these two things equal? If x is equal to 1/2. And that was choice B. Oh, well actually there are two of them that have x equals 1/2, so you have to figure out what y is equal to. So just take 1/2 and substitute it into either formula. I substituted it into the first one because I thought that was easier. So if you put 1/2 in there, you're going to get this. And it's 1/8. So that means that there's a point 1/2, 1/8. And that was choice B. Okay, this is number 16, and this one is asking about concavity. So you're going to need the second derivative. So here's the first derivative. And here's the second derivative. Okay, so you're going to set that equal to 0. And everything is divisible by 12. And then you can factor. And you're going to get two solutions, that x equals 2/3 and x equals 2. So you're going to make a wiggle graph. And remember, you're plugging into the second derivative because this is about concavity. So the signs that you get should be positive, negative, positive. So positive means that it's concave up, negative means concave down, and positive means concave up. So the question is asking, what is it concave down? So it's concave down from 2/3 until it gets to 2, in between those two. So that would be choice E. Okay, so this is number 17, and so we're trying to find a minimum. So to find a minimum, we're going to take the first derivative and set it equal to 0. So that's going to be a product rule. So it's the first times the derivative of the second plus the second times the derivative of the first. And if you simplify that, you just get 1 plus ln x, and we're setting that equal to 0. If you bring negative 1 over, you get ln x equals negative 1. So you're going to have to figure out, when does ln x equal negative 1? Okay, so of course, if you had a calculator for this, you could have just put in the original function and see what's the lowest value. But you have to see if there's a way for you to solve this. The only way you can get rid of ln is by using e. So if you add a base of e to each, you're allowed to do that as long as what you do on one side you do to the other. Do you remember that we had like a secret sort of rule that said if you have a base e here and a base e here, then the whole thing just equals whatever comes after the ln? So we're going to use that, and we're going, for the left side we have x equals e to the negative 1, which is 1 over e. And so sorry about that little delay. I had a phone call, believe it or not. Okay, so anyway, you get x equals 1 over e. Now, when you look at the choices, C says negative 1 over e. But actually, that's a typo. That would be impossible, because how could you put, looking at this is the function. Oh, I'm sorry, I misread that. Sorry, hang on one sec. Okay, sorry, I'm back. A lot going on in my own personal life. I know you think I don't have one, but I do. Okay, so the minimum value is happening when x equals 1 over e. And the question is, what is the minimum value? So you have to substitute 1 over e into the original function. So you're going to get y equals 1 over e ln of 1 over e. Okay, so remember, you don't have a calculator for this problem. So you have 1 over e, and then you have to figure out what is ln of 1 over e. So I'm going to do this in a different color. Okay, so just maybe this would be a good little review. If you have log 2 and then a 3 over here equals some value, you go around in a circle and you say 2 to the x would equal 3. So looking at this particular problem, just erase that. Remember, ln is just like log, and I'll write it as log just so it looks a little easier too. With the base of e of 1 over e equals something. So go around in the circle. So you're going to have e to what is going to equal 1 over e. Wouldn't the question mark have to be a negative 1? Because if the question mark equals negative 1, e to the negative 1 is 1 over e. So this piece here, ln of 1 over e, is equal to negative 1. So you get a negative 1 over e, and that was choice C. Okay, so this is number 18, and this will finish the sheet. So this is about asymptotes, and I've already written all the information. And so how do we get a vertical asymptote? By setting the denominator equal to 0. And you were given that the vertical asymptote happens when x equals negative 3. So let x equal negative 3. And you get c equals 3. So that's the first part. Okay, now you know that there is a horizontal asymptote at y equals 2. So you have to compare the numerator to the denominator, and you hopefully notice that there's an exponent of 1 here and an exponent of 1 here. So the way that you find a horizontal asymptote is by taking the coefficients. So the coefficient of x is a, the coefficient of this x is 1. So that means a over 1, or just a, is going to be your horizontal asymptote, except that you were told that the horizontal asymptote is 2. So therefore a has to equal 2. And the question is saying, what is a plus c? So a plus c would have to be 5, and that was choice E.